So, completing the square. So, sometimes when we have something squared, we've been taking the square root to solve it, which is a good thing to do. But occasionally, you're going to get a problem that's either not factorable or maybe you're dealing with it. It's like, ooh, this is nasty trying to get to this answer. How do I even do this? This completing the square that we're going to do is going to allow you to take a quadratic and make it where you can solve it if it's going to be a problem. So, solve each equation by using the square root property. Give exact, no decimals, solutions. All three of these, okay? I've said it, I'm going to say it again. You've got to be getting to a point that you see perfect squares and you notice them. Like here, x and 9 gives me x and 9 squared. Because hey, some of you don't make me regret the decisions I made. I can undo decisions. Especially in this class, I got seats all over the place. So here, that sign in the middle is going to tell me what we have here. And we've spoken before about where did negative 18 go. If I wrote this out as x minus 9 and x minus 9 and FOILed it, that minus 18x will be there. Okay? But the reason we like doing this is, now, I can go ahead right away and take the square root to get rid of the squared. And remember, when we get to the square root stage, there's two answers, plus minus. Got a nice perfect square, 7. So you're like, I add the 9 over it, it's plus or minus 2. No! Well, that's one of the answers, but not the plus minus part. Plus minus, there's my wall. The 9's coming over. Okay, 9, you cannot directly get to 7. The plus minus wall is there, but I can still get my two answers. Because 9 plus 7 is 16. And 9 minus 7 is 2. Don't leave it there. That's the death by 1,000 minus 1/2. If you do that on a quiz, don't do it. And we roll that way. And so for any of these, that's going to be the same way that this works. So let's say, I'm going to bounce ahead a little. I want to start working where we get some spots where things are going to be a little different. So here, again, perfect square, perfect square. I mean, could I do regular factoring on this? Sure. But it's going to take longer, and I know how much some of you just love spending all your time doing this. There's my sign. And now we're back to the exact same thing we were in number 1. So a little radical work there. I'm going to write really small because we got some stuff to do. Okay. Squared is gone. Plus minus is in. It was a perfect square. Yay. So let's see here. You're like, ooh, Hardy, this is a little more interesting. It is. I'm going to subtract my 1 over. It still ain't getting through the wall. So I look. Now, let's see. Let's not do that. Let's make two equations. So 2x plus 1 equals 4. 2x plus 1 equals negative 4. So why did I do that instead of doing what I was talking about doing with the minus 1? Because I've still got a 2 that I have to divide by. And so now if I'm breaking this into pieces and then I'm having to put the 2 in, I can get there. But typically if it's not just x, if there's a number, splitting it into two separate equations is going to make you less likely to make a boo-boo. So just something to consider. Minus my 1 over. Divide by 2. I should have put about 2 examples in this spot instead of 4. Minus my 1 over. Divide by 2. Ooh, we can even get fractional answers. Okay. But again, nothing awful. I get x, I get two numbers, and I'm good. Bless you. The last one, though, we get one new twist. And once we've got this part down, this last part with completing the square is going to be a piece of cake. So I look at the last one. 5x and 4. Take the sign in the middle. Same first part as the first two. The squared is in my way of me getting to x, so we got to take care of that. But this time, when I get to the plus or minus step, not so lucky that my radical is not a perfect square this time. But it will break down. So 2 square root of 7. So now, I got to figure out, am I going to deal with it like number 1? Or am I going to deal with it like problem number 3? They both can be worked with that way. It's kind of going to be your call. When I get the radical, I normally just leave it. But again, I'll show you both. So I'm going to minus the 4 this time. I'm going to leave this. I'm not going to split it yet. Again, that plus minus is a wall. Do not put those together yet or ever, because that's like having an x. That's like not having one. And divide by 5. It's going to be really weird looking, but it's the right answer. Oof. That was kind of yucky. If you're like, yeah, Hardy, me trying to not put those together and divide that, I don't know if I want to do that. If not, when you hit this step, do just like we did in number 3. And just make yourself 2 separate equations. Minus your 4 over. But again, you can't combine it with this. It's the like terms thing. Radical, no radical. Don't do it. Divide by 5. There's the plus 1. Minus the 4 over. Same idea. Divide by 5. Same thing. They can be 2 separate equations. They can be one with a plus minus. It makes no difference at all. Most of my answers when you're looking at the key are going to be written like this because they just take up less room. But if you want to break them apart and do them separately, that will absolutely work. And the reason we show that in advance is that's the last part of what we're going to be doing today. Kind of like yesterday when we were showing some things, we'll FOIL it out and then we'll see how it factors. Same idea here. So here's how this works. And I'll let you look forward to things. I don't know if you're going to look forward to this, if it's going to make you cringe. When we get to some more, actually I'm going to do it tomorrow. I am my side career, my backup, my backup idea in life was to be like a rapper. So I'm gonna bust out a song tomorrow with completing the square. So if you want to avoid that, don't come. I'm just saying I shouldn't tell you to not come. I just said on live video to tell you to not come to class. That's not going to be good. But yeah, I even wrote it. Yeah. If you want to sneak peek at things, if you go to my YouTube page and put in completing the square, you'll find me. You'll find me. I don't know if I'm going to do the full dress getup that I normally do for it, but we'll see how this goes. We'll see how this goes. So, okay. So, now that I've frightened some of you, and some of you are like, I got to go look up his YouTube page now. So, completing the square is a process that lets us write everything as the sum of squares, like we just did. So, this looks complicated, but it's not. It's basically we're going to take whatever your b term is, we're going to cut it in half, and we're going to square it, and we're going to add it to both sides. So watch, here's how this works. We're going to build up slowly. There's my b value. So for right now, here's all I want you to do. We're going to take your b, we're going to divide it by 2, and we're going to square it. Whatever answer you get, that makes this a perfect square trinomial, which is what we need to put it in this form. So again, take your b, divide it by 2, and square it. I will make one mention here. This number is always going to be positive because whether you write it on the paper or do it in your head, you're doing parentheses. Never negative with these. Never, 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 ever. Okay, this is, uh-oh. No decimals. Okay, square it. Here we go. You're not going to do that to us in a problem, are you? Yeah. Absolutely. 100%. But the nice thing is going to be, it's always going to come out nice. Even in fractions, it's going to come out nice. You're going to get to see that. You're going to be like, okay, this isn't quite so bad. But that's always the first step of completing the square. You have b, you square b, well, you square half b, and then you're going to add it to both sides. So we got this part. Here comes part 2. Oh, part 2. Already, it's 5 steps. No, most of these aren't. Okay? We're always going to make sure that there's no number in front of x squared. If there is, we got to divide by that a term. Whatever number is in front of x squared, you got to divide everything by that because you have to have plain x squared for completing the square to work. So then, okay, so this first one, check. It's already x squared. Sweet. Write the equation in the form x squared plus bx. The x's want to be hanging out alone by themselves. You're out on a date, you do not want your 5-year-old brother or sister hanging out with you, okay? X's don't want coefficients hanging out with them. So, if there is one, you are being banished to the other side of the equation. But, add blanks to each side. What the heck? So 12x plus blank equals -4 plus blank. That's the blanks part. And we're about to fill in the blanks here. You remember what we just did on the bottom of the last page? That's what we're going to do now here off to the side. There's my b term. So take your b, cut it in half, and square it. That's the magic blank number every time. Magic blank number to both sides. Because it still is an equation, we got to keep it equal. So once I do that, that's the hard part. Factor as a binomial square x. You're like, well, what goes there? What's half of b? Half of 12 is 6. So just take half of your b term. That's all you're going to do. And now it looks like just like the ones that we were doing at the start of class. And now it's the same thing. Now we're just like, whoop, whoop. Let's finish this bad boy off. X plus 6 equals plus minus. What's 32 broken down going to look like? Okay, 4 square root of 2 because it's 16 and 2. And so the last step now to get to my answer is just to subtract the 6 over. And again, the biggest thing with these is recognizing that looks so weird, but it's right. Don't keep going. This is not, what's that, would that be? It's not -2 square root of 2 and -10 square root of 2. Think of that like x. You wouldn't combine those if that was x. Don't do it with the radical either. So for a majority of these, that's what we're going to look like. But, you're like, oh no, not but. But, let's do 11. There's always new twists to play. I'm going to mainly do the odds here. So if you need room to go sideways and you need more room, that's not a big deal. We'll do that. X is alone. With a blank. Constant term to the other side. Make sure you do the opposite. With a blank. Oh dear. It is. Negative 12 divided by 2 is negative 6, but we're doing it in parentheses squared, so it is 36 again. X minus 6 squared, because again, it's half of that b value. Half of negative 12 is negative 6. Oh, here comes the twist. Where's that? Get that out. X minus 6 equals plus minus. Pull your eye out. So this is I square root of 9, which is 3I. We can't use the can't do it anymore undefined excuse. That gone. Add your 6 over. I is just like a variable. It even looks like one. You can't. You can hang out together, but none of that other funny business. That's got to stay. So we always combine as far as we can, but if we get that first step down, this is not going to be bad. Now, are there going to be some steps that make this a little more interesting? Yeah. I mean, I'm not going to tell you there's not. That'd be a lie. So, okay. Let's add a piece. Let's make this a little more interesting. Okay, lead coefficient not a 1. Oh. Exact solutions, in other words, no stinking decimals. Okay. Here we go. And if there was something over here, I'll do it there too. So, we've got x squared plus 7 halves x plus blank, because that 5 halves got banished to the other side of my equation. Okay. This is the first problem that people normally panic, and they're like, oh, I hate doing these with that. Just trust the system. When you're taking a fraction and you're dividing it by 2, you're multiplying it by a half. So here's how I want you to think of this. When it's a fraction, all you're doing is multiplying the denominator by 2, whatever it is. So in this case, 7 halves divided by 2 times 1/2 is 7/4, and you're just squaring each of those numbers. Now again, that looks awful, but it's not going to be. And that's not me blowing smoke at you. It is the absolute truth. When you do these correctly, they're going to clean up very nicely. So check this out. You can impress your friends with this. You can like take money from them and be like, check this out. I can tell you, leave it like that. I can tell you that number without doing any work, without a calculator. They're going to be like, yeah, right. You're like, no. Well, then find new friends. So here, again, this is why I like doing the side work, because whatever I squared in the parentheses, that's the number that's going here. It's that number cut in half, or in this case, multiply the denominator by 2. Now you're still looking at me thinking I'm crazy. You're like, what the heck? Now I am crazy because I didn't leave myself a calculator for this. Do I need a calculator? I don't need no calculator. I got this. You can put this in the calculator. Maybe that's why I want the calculator. Yeah, it is. Because I want to be able to show you stuff as you're going. So some of you don't panic. At this point, I would hope that you would know how to put the fractions into the calculator to make this simple if you know what operation you're using, but I've learned over life, if you assume things, bad things happen. So let's not assume. All right, -5 plus 49 over 16. No stinking decimals. 9 over 16. Hardy, this still ain't looking nice. Oh, it's gonna. It's gonna. Let's change up colors. Let's brighten things up. Here's where it all comes together. Plus minus. The square root of 9 is 3. The square root of 16 is 4. We have a common denominator. Hallelujah. Because now, this again, it shouldn't be bad. Because now I can go, okay, so x is -7/4, because I'm subtracting it over, plus 3/4, or -7/4 minus 3/4. And yes, I can do this. Do not leave it. When there's not a radical, there's no reason to. -4 over 4. It's -1. -10 over 4. I don't think we need a calculator, but maybe. -5/2. Okay. That's, in general, as ugly as this is going to get. And with having a calculator that does fractions and simplifies, it's really, seriously, not a big deal. Okay. Let's... Oh, how fun do we want to make this? Let's do 15. 15, I think 15. Yeah, 15. 15's the next crazy nasty one. Let's do the crazies. All right. Actually, let's go real crazy. Freeze frame. They're like, no, I don't want to do it myself. We'll do it anyway. Try 13 out. Divide that 3 through. Deal with those fractions. You can do this. I'm telling you. For those of you watching later, I hope you paused me. I want you trying this. They could, or they could just let me run and pay no attention. I mean, I know in reality that when I do certain things, like I know some of you, you've turned in your practice without doing the review, but I know some of you watch the preview and then just like, yeah, I'm good, I don't care. And I'm like, oh, hey, whatever works for people. What works for me may not work for you, and vice versa. So that's why we check out all the ways of doing stuff. You are going to have radicals in your answer. I'm just warning you. We absolutely will have time here in a moment to discuss options that we may have gone in different ways, which is absolutely possible. That's the scary thing about it. So, okay, let's... I know some of you are in the middle, but I'm going to unfreeze anyway. Okay. Have to divide everything by 3. So we have x squared minus 2/3 x minus 4. Job number 1, minus 4 to the other side. You become positive. With our blanks, of course. So if you take -2/3 and multiply it by a half, okay, so we have 2 over 6, which is 1/3, or -1/3. Square it, it becomes positive. I never want to see a negative in those blanks. So 1/9 on each side. Add those up. 36 ninths and 1/9 is 37, or you can do it on the calculator. I'll say that kind of quiet. We take our square roots. So we got our x minus 1/3. This time, your denominator breaks down. Square root of 9 is 3. The 37 doesn't. So we got to keep the radical on that part of it. And so when I add the 1/3 to the other side, I can leave it as two separate fractions with a plus minus in the middle. Perfectly fine. Or, since they have a common denominator, you can make one big fraction with your 1 plus or minus square root of 37 on top of your fraction over 3. They are the same thing. So if you see an answer key sometime that has this and you're in this, you are good to go. But it's like anything else. You've got to know the steps. How are you going to know the steps? You've got to practice it. If you try to walk into a quiz completing the square and you've never done it except for the ones we've done together, woo, good luck. Good luck. Just saying. Just saying. One last thing. I saved the easy thing for last this time. No, I did. I did. You're going to hope that all these problems were this way instead of what I just had you do because they're faster. Okay. Why the heck is y equals here now? Write the quadratic function in vertex form. Okay. And then, what is the vertex? Because again, we know at this point, hopefully, the vertex is h and k, and I take it straight from the form. That's why they call it vertex form. Okay, hint, complete the square. Okay, here's where weird starts. So, we're going to add the blanks in the first step this time. So we're going to add a blank with y. The x's still want to be by themselves, but we couldn't banish the plus 11 to the other side. So instead, we're going to build us some walls, known as parentheses, around our x's. They still get to do their own thing. From here, everything is the same as what we just were doing. I'm still going to take the b. I'm still going to divide it by 2. I'm still going to square it. It's still going to be positive. Add it to both sides. Now, remember what the goal is. We want to look like this. So, let's see here. Half a negative 8. Ooh, we're close. We're close. Like this side looks great. Okay, one thing to fix. 16's got to get out of here, so this is y equals. Bam. Vertex form. That's fast. That is fast and awesome. One last freeze. Maybe. There it goes. Try out 18. Because again, I don't want... Hardy does not want mass confusion. Sure. When we get done with this one, I sure can. But I would ask on this one that you kind of try and use 17 to do 18. Some of you, I got to get out of your comfort zones here. Like, it's not going to be clean from the first get on everything we do. Sometimes it's just going to be a downright struggle, and that's okay. We got to deal with some adversity in life sometimes. And yes, your vertex number is going to seem kooky.
Oh, okay.
Because it's going to be large. Yeah, it is going to be large. Luckily, we don't have to graph this. Because if we did, we need a very large graph. But start to think a bit as you get done with this. And as tomorrow you're hopefully looking at the quiz preview because you've done some of the practice and you're not trying to get it all done tomorrow and pay no attention to the preview. We've done a lot of stuff in a week. Lots of little pieces. We've done we've broken down radical, added, subtracted, divided, multiplied. Now we're throwing this in. That's where it's kind of good that the quiz is Monday because I know I'm not expecting you to sit in your room all weekend doing it, but you got 3 days to look over some stuff and make sure it's good. Yeah, I think this is going to be all right. I do. So, we know the drill at this point. Whoop. At least the odds. At least. Do work, show work. I have complete work answers up here if you need them, but keep in mind, when you start to peek ahead, because I know some of you do, when you look at that quiz preview, you're kind of going to be looking at that going, ooh, yeah, that's a lot of stuff. I mean, we're graphing, we're factoring, we're doing applications, we're finding, intercepts, we're solving by square roots. You got to be on your A game. It's one of those things.